Bonjour à tous. Merci de nous rejoindre en si grand nombre puisque vous êtes plus de 360 inscrits et il y a actuellement un petit peu plus de 180 personnes connectées pour cette web session organisée par Télécom Paris Alumni. Je vais maintenant passer en anglais de façon que Monsieur Melnick, qui va intervenir des États-Unis, puisse suivre ce que je vais dire. Et dans lequel je vais vous donner quelques petites consignes pour gérer vos questions. Telecom Paris Alumni has the pleasure of introducing the three distinguished guests who will entertain you today with what is intended to be the latest available state-of-the-art in some aspects of exposure of the general public to radio waves emanating from cellular networks, and how 5G is expected to bring changes to the extant situation. I am Régis Duval, your host today, and I will only briefly recall the particulars of our speakers, since you have had ample details on the enlistment page of Telecom Paris Alumni. First, Ronald Melnick, PhD, toxicologist and biologist. He has supervised as head of special projects Mtp, an agency of the US Ministry of Health, the design, preparation and launch of the largest study ever conducted on possible biological non-thermal, please keep that in mind through all the three presentations, non-thermal effects of mobile waves, 2009 through 2018, for a whopping amount of approximately $30 million, 330. Next, we'll speak Azedine Gatti, a radio expert at Orange Labs with deep involvement in 5G. He will focus on how operators apply extent protection rules in today's networks and how operators prepare for 5G specifics. And last, Jovia, professor at Telecom Paris, head of the C2M chair, will focus on the unprecedented problems raised by 5G versus exposure estimation, which needs to be done through simulations, and the challenges of measurements in the field, and more generally on the exposure evaluation issue in 5G. Now, some short indications for the webinar proceedings. So that's your interlocutors, you have them on the right. Some particulars for the proceedings. You have them in French, so I will just word them shortly in English. Each speaker will have the floor between 15 and 25 minutes for his own presentation, depending on the case, and he will drive his own presentation. So this will be at his own initiative. After each presentation, there will be a dedicated question slot for the precise speaker that just spoke, and him only. So you are invited to raise questions directed to that speaker during his intervention and raise this question to him only. You can do that in written via the question and answers, questions et réponses button. They will be read live by someone of our group, regrouped, processed, and reformulated into some 3, 4, 5 questions directed to the said incumbent speaker. At the end of this session, there will be an approximately 15-minute slot for wholesale questions that could be addressed by any of the speakers. Thus, during the first 2 presentations, please concentrate on questions specific of those speakers. During the third one, which will be the one of Jovia, you may freely formulate any type of question. Nominal timing is 5:30 through 7 o'clock. We started with some 5-6 minutes delay. We have accounted for some 5-10 minutes over time. We will close at the very latest at 7:15. Now we will start with the expose of Mr. Melnick, and he will take the floor. Mr. Melnick, please start. So I surrender the screen sharing. You may take it.
Thank you, Regis, for inviting me to participate in this webinar and to talk about the National Toxicology Program studies on cell phone radiation. The National Toxicology Program began in 1978 as a means of bringing together toxicology groups in various agencies in the Department of Health and Human Services. This included the Food and Drug Administration, the Center for Disease Control, and the National Institutes of Health. It's headquartered at NIEHS, and over the years has conducted 600 cancer bioassays. The NTP receives nominations from all groups with respect to agents for study. This could be government, academics. The nomination for cell phone radiation came from the Centers for Disease and Radiological Health at the US FDA, and they requested toxicity and carcinogenicity studies in experimental animals to provide the basis for human health risk assessment. And the reason for this was that exposure guidelines were based on protection from acute injury from thermal effects and may not be protective against non-thermal effects of chronic exposures. So the approach that we took was first to examine what was the guidelines established by the Federal Communication Commission, and this was established in 1997. And it was based on an increase in body weight that was measured to be 1 degree centigrade and estimated to be a dose, SAR, of 4 watts per kilogram averaged over the whole body. Based on that, the exposure limits for the general population were essentially divided by 50 to come up with 0.08 watts per kilogram averaged over the whole body. And for 1 gram of tissue, 1.6 watts per gram was the guideline exposure limit. In Europe, it's 2 watts per kilogram averaged over 10 grams. Now, the issue of this is extremely important because when you hold a wireless device next to your head, the emission is greatest in the region where that antenna is held. And our focus was on understanding organ-specific exposure and felt that the 1.6 watt per kilogram was the most appropriate. So the objectives of the Mtp study were basically to test the hypothesis or the assumption that cell phone radiation at non-thermal exposures or minimally thermal exposures were incapable of inducing any adverse effects. And this assumption was based on the knowledge that radio frequency radiation did not have sufficient energy to break chemical bonds. So the exposure system that we started to work with, and I was interacting with engineers and physicists from the National Institute of Standards and Technology, was we wanted to expose larger groups of animals, 100 per group. They must be unrestrained because previous studies exposed animals in tubes, and they must have access to their feed and water. We discussed having a shielded system that had to have a homogeneous environment in all directions to expose animals equivalently. The power levels were not to exceed the animal's ability to thermoregulate. All equipment and materials inside the cages had to have minimal RF absorption. We had to have proper temperature, humidity, noise control. And the frequencies that were selected were those to reflect those that were in use, the 900 and 1900 megahertz, as well as the modulations, the CDMA, which I believe is similar to UMTS, and GSM modulation. And we were planning to have 3 power levels plus a sham chamber for each sex and species. Now, we interacted also with the group at ITIS in Zurich, Switzerland, and modeled what would happen with exposures in a reverberation chamber for rats or mice exposed to either 900 or 1900 megahertz And what you can see over here is for the mouse at 900 megahertz, most very high radiation absorption is in the tail. The tail is acting as an antenna. Similarly, for the rat, the 1900 1.9 gigahertz had high absorption in the tail. Oops, go back one. But in the brain, the SAR was essentially the same as the whole body. This is a graph showing the relationship between organ dosimetry versus whole body dosimetry. And the brain was our primary interest because at that time there had been reports of brain cancers associated with cell phone radiation. The exposure chambers that were designed look like this. These are shielded rooms which contained a excitation antenna and panels, vertical, horizontal and vertical panels that distribute the fields to create a statistically homogeneous environment of electromagnetic environment. And in this kind of system, there is no daily exposure limit. We could expose animals for many hours. You got to remember, in a study, we wanted to challenge the hypothesis, and because of the limit in exposure intensity for heating, we felt under this system, we could increase the number of hours per day that an animal would be exposed. And this is a view inside with 2 cage racks that could hold 100 rats or 200 mice. The final system developed here in Chicago contained 21 of these chambers, 7 for male rats, 7 for female rats, and 7 for mice. The study also then had to demonstrate and validate that the average field uniformity differed by less than 1 dB at the 900 and 1900 megahertz. And this was established prior to the study of animals using simulation bottles filled with simulation fluids. And we had 216 in a chamber to show that you could create this homogeneous environment. There would be continuous monitoring of field uniformity throughout the studies to increase the exposure duration. The duration was 18 hours a day, but it was on a cycle of 10 minutes on and 10 minutes off. The first phase of the study was a thermal pilot to determine the effects of different exposure levels of both GSM and CDMA modulations on body temperature in spray dolly rats and B6, C3F1 of different age and pregnancy status. And we used implanted temperature microchips. The intention was to keep body temperature below 1 degree centigrade. And the microchip approach had been demonstrated in a previous publication by others to be equivalent to a thermometer, a rectal thermometer measurement. The second phase was what we call pre-chronic, to determine if rats or mice could tolerate the exposures over a 28-day period. And then was the chronic study, the 2-year cancer study, which had 90 animals per group. The exposures in rats began during gestation and continued after weaning for 2 years, used both GSM and CDMA modulations. It turned out that the selection was for spray dolly rats, 0, 1.53, and 6 watts per kilogram. And this was based on the information from the pilot study and the finding from the pre-chronic study that there was no essential toxicity at this level. For mice, the exposures were 0, 2.55, and 10 watts per kilogram. Every animal in the study received the complete necropsy and histopathology. And there was also a 14-week sacrifice looking for DNA strand breaks because that had been reported previously. The first set of data, and when I show data, if there's a asterisk in the sham control, that means it's a significant trend. If it's in a group, it means it's based on a pairwise comparison of that exposure level to the sham control. You can see that there were decreases in pup weights, both trend and significant. There was also an increase in cardiomyopathy. This is a heart muscle disease, and it increased in both severity and incidence in male rats, and there was also an increase in incidence in female rats. In the studies for DNA damage, this was conducted using the COMET assay, and the red boxes indicate where there was both a significant increase in one or more dose groups and a significant trend. The green indicated that there was only a significant trend, and the yellow are some that I selected because the increases were greater than twofold, but they did not reach statistical significance. So the red squares are the most important, showing DNA strand breaks by the COMET assay in exposed rats and mice.
Ron, I have to ask you to go a little bit faster, please.
Yes. There were proliferative lesions in the tumors and hyperplasias in the hearts of the male rats. And this was one of the major findings. It was significant in the CDMA 6 watt per kilogram. There were significant dose trends, and the hyperplasias, which are pre-malignant conditions, were also observed, and this shows the level of total proliferative lesions. There were also brain tumors observed and proliferative lesions observed with both the GSM and CDMA. And there was also increase in tumors, adenoma carcinomas of the prostate gland, as well as proliferative lesions in exposed groups. And this is unusual since NTP has never seen a prostate carcinogen. Now, there's been comments made about the effect that the animals live longer in the controls compared to the exposed groups. But here is the 6 watt per kilogram dose group, and you can see it was less than the controls, the dark squares, except at 93 weeks they overlapped, and that's when the difference occurred. As well as there was finding of precancerous lesions and heart schwannomas observed earlier in the study at 58 weeks and at 70 weeks in exposed rats, but none in the controls. Therefore, it seemed that there was survival differences were not sufficient to discount the tumor response. Their survival was sufficient to detect tumors or precancerous lesions. So the NTP has levels of evidence for carcinogenic activity. The criteria are clear evidence, some evidence, equivocal. Clear is there's a dose-related increase in malignant tumors. Some is a little bit weaker evidence. Equivocal means that there is a marginal increase, but may or may not be agent-related. But the NTP uses more than statistics to evaluate their studies. It's whether these are uncommon tumors, which the heart schwannomas and the glial cell tumors were, whether there were proliferative lesions, hyperplasias, pre-malignant lesions at the same site, or genotoxicity. The overall outcome as a result of a 3-day peer review was that there was clear evidence for heart schwannomas with both GSM and CDMA, some evidence for gliomas with both GSM and CDMA in male rats. There were incidences in female rats. However, the peer review group felt that this was an equivocal response, even though the background rate was essentially 0. The prostate gland was considered equivocal. So overall, the key findings are that the radiation caused cancers and preneoplastic lesions in the heart and brain, proliferative lesions in the prostate gland, DNA damage in brain cells of rats and mice, heart muscle disease, and reduced birth weights. Therefore, the assumption, that the non-ionizing radiation cannot cause cancer or other adverse health effects other than tissue heating seems to be wrong. Now, there is a concordance between the NTP studies and human studies. In the Mtp studies, there were cancers of the heart, which were schwannomas, and brain gliomas. In 2011, the International Agency for Research on Cancer concluded that radiofrequency radiation is possibly carcinogenic to humans based on increases largely of glioma and acoustic neuroma, which is a vestibular schwannoma, in both the Interphone and Swedish studies. The Interphone was a multinational study coordinated by IARC. The animal data at that time were considered limited, and the human studies were considered limited because these were based on case control studies, which could not rule out with confidence the possibility of bias due to selection or recall. However, there have been other studies that have been conducted since the IARC review in 2011. There was an increased risk of glioma in a French national study. Mamoli from Canada examined the influence of recall and selection bias on their participation in the Interphone study and found that it was not effective. Phillips has reported that there's an increase in glioblastoma in the frontal and temporal lobes that has doubled in England between 1995 and 2015. There have been additional animal studies. The Ramazzini study found an increase in heart schwannomas in rats exposed to GSM modulated radiofrequency radiation. And Lurkel was able to reproduce a co-carcinogenic effect that had been reported previously by Tillman. And mechanistic studies also indicate that there have been numerous papers showing oxidative stress, and this is one which can lead to chromosomal damage and mutations. And I point these three out because these are the three aspects that IARC uses for judging what the classification of a agent. So in the future, how might this affect IARC? If IARC still considers the human evidence to be limited, but the animal evidence to be sufficient, this would be equivalent to a group 2A. In order to be considered an IARC group 1 or human carcinogen, there must be sufficient evidence of cancer in humans, and that would be up to the IARC the epidemiology selected by IARC participating in that review, or sufficient evidence in animals if there's strong mechanistic evidence. So what the public needs to know is that multiple studies have found increases in cancer incidence associated with exposure to radiofrequency radiation in animals and humans. And we don't know the level of cancer risk, but because of the widespread use of cell phones, even a small increased risk could have a serious public health impact. And I believe precautionary principles should be promoted, not if you are concerned statement by health and regulatory agencies, especially for children and pregnant women, because cancer risks may be greater for children than adults due to the increased penetration of cell phone radiation within brains of children, and the developing nervous system is more susceptible to tissue damaging agents. So lastly, what I think the lesson learned from this is we can no longer assume that any current or future wireless technology, including 5G, is safe without adequate testing. And I believe that the FDA, who nominated the study to the NTP, should now acknowledge the results of the study they requested and develop health protective exposure standards. Thank you.
Thank you, Ron. Please keep the display as is, since this is basically the conclusion of your expose. We are starting to try to process the questions. We have one already, which I will formulate. It's a bit long because it needs to be a bit precise in the wording. The Mtp study has been turned public 2 years ago already, and even in that lapse of time of 2 years, it has failed to gain any significant support across the world official organizations. Thermal effects are still the only ones recognized worldwide after the update of official views published in 2020, and the Mtp study has not changed that so far. In addition, the study's methodology itself has been criticized on several accounts, such as lack of control of body temperature of the test animals. And even if those critics for the methodology are put aside, the results themselves, which is basically the statistics and the interpretation of them that the NTP has done, have been rated. And this is supported by multiple national entities such as ANSES in France and the BFS in Germany as more or less inconclusive. Can you comment for others the views of the NTP on those critics for the basically the recognition status of the NTP study?
Well, yeah, those are a lot of questions that you boiled into one long discourse. But the NTP study underwent a 3-day independent, rigorous review. There were 7 academics, including Frank Barnes and Jim Lin, 7 from industry who all reported no conflict of interest. They evaluated the exposure system, the interpretation of the cancer studies. On the board were veterinarians, toxicologists, and they compared the results against the NTP criteria and came to the conclusion that there was clear evidence of carcinogenicity for the heart schwannomas and some evidence for the gliomas in male rats. With respect to the statistics, as I mentioned, NTP does not rely 100% on p-values. Yes, p-values are important and they do guide the interpretation of studies. But in addition to that, you consider the rarity of a tumor from of its background rate. The gliomas and the heart schwannomas are extremely uncommon in control animals, and that adds to the credibility of that finding. Also, as I mentioned, there were pre-neoplastic lesions. These are the hyperplasias. There's a continuum from initial development of a local hyperplasia, which grows into an adenoma and eventually into a potential carcinoma. NTP takes that into consideration. Although the cancer risk assessment would be based on tumors, the finding of hyperplasias or preneoplastic lesions at the same site adds to the evidence. They look at dose response or trends, if there's a positive trend analysis, and genotoxicity sometimes also is taken into account. And in this case, where there was examination for genotoxicity, there was the finding of DNA strand breaks in brains of exposed animals. Why agencies have not, I've written a letter to the FDA since the FDA nominated this, and they made a statement simply that they cannot use the NTP data, even though it was designed specifically to provide organ-specific dosimetry. The FDA, and I know others criticized this histopathology blinding in terms of whether the pathologist knew what the doses were. The NTP undergoes a 3-step process for evaluating the pathology of lesions. The first is by the study scientist who reviews them all. That person does know what dose groups the animal came from. Second is a QA pathologist who reviews all of the identified lesions plus 10% of unlesioned animals to see if something was missed. And then there's a pathology working group, which has approximately a dozen pathologists who review the findings and confirm the pathology final conclusion. And they did not even know what the agent was.
Ron, I have to interrupt you. I would just have you comment in a few specifics on that, which is there have been raised against the the reliability of the Mtp study, some specific critics versus control of the body temperature of the animals, also some control of the statistics, the inconsistencies with the survival rate of animals, a number of items in which the details of which it is not relevant to enter now, but we suppose that all those issues have been raised during the review of the study of the Mtp, and that each one of those items has been intensely discussed and analyzed before rendering the final rating of issues.
Yes, they were raised, but since I want to comment one on the temperature effect. The animals were evaluated for a temperature effect prior to the study, and there were probes, microchips in animals during the exposure. But you got to remember that there was no evidence of thermal stress or metabolic stress in the animals. They tolerated the dose. This is what a toxicity study is about. There was no significant effects on body weight in the 2-year study. There was no tissue damage in the 28-day study. There were no clinical observations, no exposure-related clinical observations. These are something that you might have expected if there had been stress to the animals. This was not observed, and as Ichner actually has stated, that they are not aware of any research that has tested whether chronic body temperature elevations can affect carcinogenicity. So we're not saying stress. It's an alternative hypothesis that hasn't been tested.
So basically, and we will close with this statement, the Mtp is a clear affirmation that the results are reliable, that they are non-thermal effect related, that they evidence some other type of mechanism.
They're not heat related, but there can be an elevation of up to 1 degree centigrade in body temperature. So it's minimally thermal is the conclusion rather than totally athermal.
Okay, thank you. Thank you, Ron. Thank you for those additional explanations. We shall move to the presentation by Azedine Gatti. Azedine, can you release the control of the screen, Ron, please? Thank you. Azedine, can you take the floor? Okay, your mic is opened.
Est-ce que vous voyez mon écran, Régis?
We do.
Okay. So I will switch to French, if you don't mind. Sorry, it's not this one, but sorry. Okay. Is it okay for you?
Yes.
Okay. I have a problem, sorry. Yeah, it's okay for me. Ok, donc bonjour tout le monde. Je switch de l'anglais au français parce que c'était ça la demande, Régis. Hein. Et voilà, et je vais vous parler, je vais sortir du domaine de la biologie vers le domaine de la physique, puisque je travaille donc chez un opérateur que vous connaissez, enfin j'espère, Orange, et je vais vous parler notamment de qu'est-ce qu'on fait en fait dans le domaine de la protection des personnes contre les rayonnements non ionisants et notamment ce qu'on appelle d'une façon un peu rapide les EMF, parce que les EMF en fait ça vient de l'anglais hein, Electromagnetic Fields, donc contre les rayonnements non ionisants, les ondes électromagnétiques plus clairement, voilà. Et comment on gère le problème, notamment avec les réseaux 2G, 3G, 4G et maintenant avec la 5G. Voilà. Donc, comme vous savez, donc la 5G vient en plus de réseaux déjà existants, hein, qui sont la deuxième génération, la 3G, la 4G, la 5G, même si naturellement, en fait, la 2G, la 3G sont en train de disparaître petit à petit, parce qu'en fait, on les réduit hein, au minimum. Et la 4G et la 5G, un peu, enfin la 4G aujourd'hui, c'est celle qui porte la majorité, l'écrasante majorité du trafic, et la 5G va suppléer à la 4G dans les années futures. Pour l'impact, j'ai résumé l'impact en trois. Hein, il y a l'impact énergétique, qui est un débat sociétal aujourd'hui. Hein. L'impact sociétal, mais ce que j'appelle dans le sociétal, enfin, je vais parler ici des ondes électromagnétiques, mais en fait, ça va au-delà des ondes électromagnétiques, l'impact sociétal, et puis bien sûr l'impact économique de cette nouvelle technologie. Voilà. Avant de commencer à parler de la technologie, donc vous savez, enfin, vous avez eu écho des fréquences. Hein, donc la 5G peut être déployée potentiellement sur 3 fréquences différentes, hein, ou 3 bandes de fréquences plus précisément. Donc il y a les bandes basses qui sont le 700 MHz. Pardon, Régis, je n'ai pas activé, je pense, ma vidéo.
Non.
Excusez-moi. Ouais, je crois que j'ai oublié d'activer ma vidéo. Et voilà. J'espère que ça se voit. Voilà. Et je reprends ma présentation. Voilà. OK. Et donc, voilà. Donc, je disais que c'était déployé sur 3 fréquences. Les fréquences basses, le 700
Tu peux
MHz.
penser à faire défiler tes planches, s'il te plaît?
Je défile là.
D'accord. Il y a peut-être un problème d'affichage chez moi. OK.
Non, ça n'est pas que chez toi.
Ah,
Il y a aussi un problème chez moi.
So it seems there is a display issue on the tool.
Vous voyez pas la slide? Je suis à la slide.
C'est bloqué sur la page 1. Je suggère que tu fermes ton PDF et que tu le rouvres.
Par contre, je suis pas en PDF, hein, je suis en PowerPoint. Et peut-être qu'il faut que je switch sur le PDF.
Peut-être.
Ferme un écran.
Je ferme un écran. Voilà. Là, du coup, je ne sais pas quoi faire. Est-ce que je...
Passe en PDF si tu veux bien.
You are not sharing your screen.
Yes. Okay. I share again. Is it okay?
Yes.
Yes, it's displayed. Peux-tu défiler, s'il te plaît?
Voilà.
Là, voilà. Là, ça bouge.
Est-ce que je passe en affichage plein écran?
Tu peux.
Allez, on y croit. Ça passe?
Oui.
Merci.
Ok. Bon, ben, pardon. Hein.
Voilà, non, il n'y a pas de souci.
Donc, voilà, c'était l'impact. Bon, je peux passer rapidement. Donc, il y a les 3 fréquences. Donc, les fréquences basses à 700 MHz. Les fréquences, on va dire les fréquences stars, c'est entre 3,4 et 3,6 GHz. Et puis, les fréquences hautes qui sont au-delà du 6 GHz. On parle beaucoup des fréquences autour de 26 GHz. Voilà. Donc, en fait, la 5G pourra être déployée potentiellement sur les 3 fréquences. Hein. Aujourd'hui, la fréquence pour laquelle on va avoir le plus de capacité ou le plus de performance, c'est la bande du milieu, là, le 3,4, 3,5. C'est la fréquence star. Les fréquences en bas, honnêtement, la 5G va ressembler beaucoup à la 4G. Hein, ou les fréquences, un peu les fréquences 4G, parce qu'on peut mixer la 4G avec la 5G. Et en fait, à ces fréquences-là, on va avoir des performances qui sont assez équivalentes à la 4G. C'est une pseudo 4G. Quoi. La vraie 5G...
Tu accélères. Il faut que tu accélères, Zedine.
J'accélère. Allez, hop. La vraie 5G, c'est pour le 3.5. Allez, hop. Pour je rappelle donc ici les avis des autorités sanitaires. Hein. Aujourd'hui, il y a 16, et c'est même plus vrai d'ailleurs aujourd'hui, il y a 16 autorités sanitaires qui se sont déjà prononcées sur les effets sanitaires des ondes électromagnétiques et et la phrase est claire, en dessous des limites, il n'y a aucun effet avéré aujourd'hui. Voilà. L'ANSES en France, c'est l'autorité sanitaire qui gère le problème des ondes et autres hein, pour l'aspect, on va dire, biologique. Et l'ANSES a émis un rapport en 2013 qui disait la même chose, hein, qui corroborait en fait les autres autorités sanitaires. Maintenant, elle a été saisie par le gouvernement pour se prononcer spécifiquement sur la 5G. Elle rendra son rapport en 2021. En attendant, on se base sur les avis des autorités sanitaires en France et à l'étranger. Voilà. Qui disent qu'il n'y a pas d'effet en dessous des limites. Voilà. Si ça devait changer, ben, on s'adaptera. Voilà. Les limites, ben, ça dépend de la fréquence. Hein. Et un point à savoir, c'est que pour respecter les limites, un opérateur, il doit prendre en compte toutes les émissions et non pas seulement juste une technologie, la 2G, la 3G ou la 4G. On doit prendre en compte l'ensemble des technologies qui sont installées sur un site. Un rapport qui a été sorti dernièrement qui est assez récent. Et ce rapport-là, il est co-signé par les 3 ministères, hein, le ministère de la Santé, de l'Économie et du Développement durable. Et je vous ai remis en fait les phrases tirées de conclusion de ce rapport-là, avec le lien Internet pour y aller, et qui rappellent, je les ai même mises en français pour ne pas faire de faute voilà, de transcription, et qui rappelle qu'il n'y a pas d'effet en dessous des limites qui sont appliquées aujourd'hui en France pour les ondes électromagnétiques. Voilà. Pour la 5G, alors qu'est-ce que c'est que la 5G? Quelle est la spécificité en fait de la 5G? Vous en entendez toujours, enfin, peut-être parler beaucoup, hein, c'est la 5G, c'est le beamforming, et le beamforming, c'est cette espèce de beam là qui bouge, et le massive MIMO. Voilà, c'est des termes que vous allez trouver dans les journaux. Qu'est-ce que ça veut dire exactement? Je vous ai fait ici un petit schéma comparatif. En fait, la 4G, c'est comme une onde en fait qui est émise de partout et tout le temps, voilà. Et donc, la 5G, elle a une spécificité, c'est qu'elle a un beam qui est orientable et qui va s'orienter plus à l'usage. C'est-à-dire que c'est le mobile qui va contrôler ce beam-là. Le mobile va appeler l'antenne et l'antenne va choisir quel est le meilleur beam pour servir l'utilisateur. Un beam, c'est quoi? C'est un faisceau. Donc, il y a plusieurs faisceaux et l'antenne va choisir le meilleur faisceau qui va servir le client. Elle ne va pas savoir quel est le meilleur faisceau ou quelle est la direction de ce faisceau-là. Elle va en tester plein et celui qui répondra le mieux, c'est celui qu'elle va choisir. Voilà. L'exposition, elle va être permanente avec la 4G partout. Enfin, on a une espèce d'exposition tout le temps, à peu près pareil. Hein. Ça varie durant la journée.
Azedine, on me réclame ton anglais, donc est-ce que tu pourrais passer en anglais, s'il te plaît?
Okay, bon. So I was saying that the difference between the 4G and the 5G is that in the 4G we have a kind of a wave which is distributed uniformly everywhere, and in 5G we have a kind of a higher exposure which could be local, a local higher exposure, but which is more localized, and it is on demand. This is really the novelty. I would say that massive MIMO was something that was invented by the green people who are working on the green activities and reducing the power consumption. And the idea at the beginning is not to transmit the signal everywhere, but to transmit the signals only when it is needed and where it is needed, and nothing else. This was the idea of the beginning of the massive MIMO. Okay, so the problem in the evaluation of the exposure is that now we are moving for something which is more or less constant to something that is more statistically distributed. So there are there is a shift in the paradigm of evaluation of the exposure. We were in a static evaluation, and now we are more and more moving to something which is statistically distributed. It's not yet in the standard, but I mean we still using methodologies for assessing the exposure which are based on the maximum approach. It's not yet applied for statistics, but maybe one day we will move for those statistics. security perimeters, which are really the most important thing for an operator like Orange, a carrier like Orange. Security perimeter, what is it? Is the delimited, the exclusion, the exclusion zone where we can potentially exceed the limits. So before going to that, let me give you some key points. Today, 5G is subject to the same regulation as 2G, 3G, and 4G, under the control of the national authorities. I'm talking about the INFR, which is the national authority in France, who is controlling and giving the protocols and setting up the protocols for evaluating and assessing the exposure. All the technologies have to be cumulated, of course. We have not to take into account only the 2G or 3G, but every emission and every antenna that is installed. And of course, a security zone that have to be delimited on the rooftops to assess, to define the exclusion zone. I will not go into the details. So today, the limit is 61 volt per meter in the frequency going from the 2 gig to 300 gigs. And of course, we have in some regions, we have some differences. From, for example, the Paris Charter. I'm talking about Belgium. I'm talking about, Italy. In Europe, we have different regulation and different limits in different countries, which are not harmonized yet. So in France, for example, we have different regulation. We have adopted the international limits, but the INFR set it a kind of an atypical point. If we exceed 6 volt per meter, then we have to change something. To reduce the exposure. I'm going very, very fast. This is what we call the security perimeter, what we set on rooftops around our transmitters. So we have different shapes that have been defined by the INFR, and we have to calculate, cumulating all the technologies to calculate this kind of shape for every single base station that we install on the rooftop. This is just an image, a picture of how we do it on real and operating networks. So you see here the transmitter, and you have a kind of the exclusion zone materialization by a chainnet here, and some pictograms that are set there to show that there is a zone where nobody have to cross. Okay, what about the environmental exposure? So I show you here an internet site that we have set it in orange to share this, all those information about EMF. It is in 6 languages, so you can click on it and you will have a lot of information also about fake news on the exposure and on the relation between the exposure and some phenomena like coronavirus and so on. Okay, so I give you here just a picture that was presented by the INFR, who is, as I said, the authority who is controlling the emissions in France. So they are doing, thousands of measurements every year, and they give us a kind of a picture of how it is evaluating. So you see that really the exposure is very, very, very low. It's around 1 and 2 or 2 volt per meter. Remember that the limit is 61 volt per meter. So it is between 1 and 2, depending on the technology and the evolution in the years from 2014 until now. There is no really an evidence that it is increasing or decreasing. There is no evidence that it is increasing. So it is more or less stable. And this is, logic, because the traffic is moving from one technology to another technology. Of course, there is more and more use of mobile technology, but the mobile technology is adapting itself to, with the different features, like, for example, the power control and these kind of things that can, reduce the exposure of population. Okay, about the 5G, because the previous slide was about the legacy, about what is existing now, but what about the 5G? As you know, we are installing now the 5G. We are activating it even in some places, in some areas. So we are doing this in complete transparency with INFR. So we have here a picture of some figures and some figures that are given from the INFR report about the measurement without traffic and the measurement with traffic. So you see that without traffic, there is almost nothing. 0.06 is really something really very low. And even with the traffic, you see at 150 meters, which is close to the transmitter, we still have some values that you have here. I put it here, and you have it in the report of the INFR. You can see it on their website.
May I raise, just to be clear on this one, the values for the 5G with signalization. This is signalization searching for customers on the whole sector, but that does not include the power for data transfer.
Yes.
Okay.
Exact. I said no traffic here.
Okay.
So it's written, it's without traffic.
Okay,
This is
fine.
only with signaling, and this is with traffic.
It's just that the audience gets clearly the message that this is in no traffic conditions.
No, this is with no traffic conditions, and this is with traffic conditions. The blue table is with traffic.
Okay.
So we can stimulate the antenna to transmit the power at the maximum power. We can stimulate also the traffic and put the traffic at 100%. This is what has been done with the INFR, no traffic situation and with traffic situation.
Okay, so basically what the audience can keep in mind is that at 150 meters with traffic conditions, the field is in the range of 10 volt per meters, 5, 6, 7.
I don't know if no, I would not say 10 volt per meter, but it's around 1-2 volt per meter. It's not 10 volt per meter. This is infinity. Yeah.
Okay.
Okay. Let's go to the another message that was shared also by the INFR, which is very important. Is the question is, as you know, that the traffic is increasing, and this is really the main lever that make us deploy the 5G. It's because we have a traffic increase of more or less 40% per year. Okay, so we have in some situation we have a problem of saturation in some sites, and even our trend is that in 2 years we will have a big deal with the 4G network. It will not support all the traffic. So the problem of the 5G is both twice. One is it better to deploy the 5G in terms of energy consumption, and the second about EMF. So this report showed that if we deploy, we continue to deploy the 5G, the 4G, for example, we can have an increase of plus 70% VS actual. The reference is very important. And this is an internal study which has been published. We show that if we continue to deploy the 4G, the energy consumption of the total network will be drastically higher than if we deploy the 5G from now. So this is very important, I mean, to show that even if 5G is now, is deployed now, I mean, it's better to deploy the 5G now than to delay its deployment and rollout in the coming years.
Okay.
Okay.
I
And
suggest we close.
Last slide. Yes, my main message is that I think that Ron has presented something about his presentation on the Mtp about the health effects which are over there. I give you the situation today about the EMF, the real EMF in operating network. As you know, that from the health effects to the international limits, we have a safety margin of 150. This is for the actual ECNIRP guidelines. We have a factor of 2 if we consider that for assessing the EMF, we consider always the maximum and not the average. We consider the maximum that is allowed by a base station, which never happened. In the evaluation of the guidelines, I tell you that in many countries and in France also, we have not a local regulation, not a local policy, but a kind of, in France we call this un point atypique. So if we exceed 6 volts per meter, we have to change our installation. I want to add also that the EMF is also reduced by the distance. As far as you are from a transmitter, lower is your exposure. And the last one is the propagation from outside to inside, which divide by 2 to divide by 100 the EMF that you can get in the indoor situation. So basically, from the health effects to the situation where we have an EMF, I mean, there is a factor of more than 1 million in our situation. You
have to close as it, and then you have to terminate, so with that we can address at least a couple of questions.
Yeah, I finish. My advice is, I hope one day, especially in Europe, because it's happened only in Europe, to harmonize the limits everywhere in Europe. And that's all. J'ai fini ici. Si vous avez...
Thank you very much, Azedine. We have a couple of questions. The first one relates, you have treated the question of the relationship between basically the bit rate and the level of required fields, so that this is in the table you presented.
Okay.
There is the notion, but I'd like to go to 2 specific points. The first one is 5G will create some kind of hotspots, which is basically what is currently tackled as point atypique in the wording of the ANFR. What do operators do to pre-detect potential point atypique? Is there some kind of logic with the introduction of 5G to move from basically a discovery of point atypique through local measurements among the 3,000 or so done by the ANFR each year, to move to a prediction and detection on a systematic basis?
Mm-hmm. Okay. Yes, for the first question, I mean, for the same, you want me to answer in English, Regis?
Si possible.
Oui, okay. So higher is the data rate, I mean, for the same volume, higher is the data rate, lower is the time of exposure. So the exposure will be at least lower. I want to add something about the high data rate. If your mobile phone, your cell phone has the ability to have a high data rate, this means that your mobile phone is in good conditions. You cannot have high data rates in bad conditions. So this means that you are close to a base station. And this means that your exposure to your mobile phone is reduced. The horrible situation is the mobile phone is in bad conditions. En français, quand vous avez juste une petite barre sur votre téléphone, just one bar, saying that your mobile is really in very bad conditions, this will induce a high power at the mobile phone. Of course, even in 100% power, if the mobile is transmitting 100% of its power, it is compliant. There is no problem of compliance. I'm not talking about compliance here. But if you want to reduce your exposure to the mobile phone, use it in good conditions and not in bad conditions.
Okay. Can you talk a bit of point atypique, Azedine?
Yes, the second point about the point atypique, for us as an operator, before deploying any antenna, we do simulations. We can evaluate the exposure everywhere in 3D and on rooftops and we can evaluate, and then we remove the 6 volt per meter. We adapt the power, we adapt the antenna. This is one thing that we do before installing. Once it is installed, INFR do, as I said, thousands of measurements every year. If they found that there is a point, a critical point, atypical point, they contact all the operators saying, guys, you have to change this site to reduce the exposure under the 6 volt per meter.
Okay, and a second question, very rapidly. Maintenance staff that do the interventions and the operations on the antennas are in an intermittent way exposed to much higher fields than the public in general. Those people are most generally nowadays external societies. They are hired by the operators. Is there some view how these staff and their activities are tracked since they are dispersed in multiple very small companies?
Yes. Là, tu m'excuses, Régis, je dois switcher en français parce que je ne sais pas dire un plan de prévention en anglais.
Pas de souci.
C'est parce que c'est très important. Nous avons, enfin nous, quand je dis nous, les opérateurs, hein, nous avons tous des plans de prévention et des formations dédiées spécifiquement à nos travailleurs. Ok ? C'est-à-dire que quelqu'un qui va intervenir sur un site, il est formé pour le faire. C'est pas n'importe qui peut intervenir, premièrement. Deuxièmement, donc ils sont au courant, hein, avant d'y aller, parce qu'il y a des périmètres de sécurité, ils peuvent s'approcher pour éteindre, s'il le faut, la station avant même qu'ils interviennent. Voilà, c'est des choses qui sont incluses dans le plan d'intervention qui a été partagé avec la médecine du travail et les gens qui font la formation. Voilà. La deuxième chose, c'est que le plan d'intervention, quand on fait intervenir des sociétés prestataires, on le partage avec eux. On n'est pas comment dirais-je, on n'est pas la société qui gère le plan de prévention pour cette société-là, mais on partage avec eux notre plan de prévention. C'est dans le cahier des charges. Voilà, on partage avec eux dans notre cahier des charges le plan de prévention pour qu'ils sachent comment intervenir sur un site. Et troisième chose, pour certains, et on a des badges, enfin pour Orange, je vais parler pour Orange, pour ça, nous avons un badge qui se porte sur le bras. Et ce badge-là, en fait, il s'allume, il s'éteint, enfin, il s'allume pour dire quel est le niveau d'exposition au cas où, voilà, l'antenne n'a pas été éteinte par mégarde, il est intervenu sur un site et l'antenne n'a pas été éteinte, il y a le badge pour le prévenir en cas de besoin. Voilà, c'est le plan de prévention qui gère tout ça. Voilà.
Merci beaucoup, Azedine. Thanks very much, Azedine. Joey, can we switch to you? Azedine, can you release the control?
Yes, how can I do that?
I cannot. Ok.
Je ne sais toujours pas. Tu l'as, Joe?
Vous ne pouvez pas démarrer. Ok. You see my screen? Do you see my screen? Yes?
Yes.
Okay.
Go ahead.
Okay. So, first of all, thanks to the alumni to have invited me. I will try to explain in a short time because before I have used large time. I will explain what we can expect from 5G about EMF exposure. First of all, I am in telecom, as has been said. I am chairing the chair that is dedicated to the modelization, characterization, and monitoring and mastering the exposure, the EMF exposure. So my talk will be in more or less in three parts. So what is the field, the electromagnetic field, the EMF emitted by base station and mobile? What is the current situation and expected impact of 5G? And after that, I will move to RF exposure, because first of all is the field emitted, and after that is what you absorb in order to be able to discuss the biological study that has been carried out. So we'll discuss method, current assessment, and expected impact of 5G. And after that, I will finish with some what we are doing on artificial intelligence to open the discussion. So first is the electromagnetic field. Since I don't know what was the background of about more than 250 people, I try to have a large explanation. So first of all, electromagnetic field is propagating energy at a given frequency. So wave is like you put a stone in the water, what you will see is wave. The wave is not propagating in the horizontal plane. You see the wave moving, but the water does not move. In fact, if you put a cork on the water, you will see the cork go up and down, and in fact, this is the energy. And these EMF are generated by antenna. So they act as a link between the mobile and base station. I go quick because I think it's important to put this. And at the end, what we have is the power density, what you receive. In fact, the power density is proportional to the E square, to the electric field square, is proportional, inverse proportional to the distance to the base station. So it's important to keep in mind, far you are from the base station, lower will be the field emitted, the field you receive, and closer you are to your mobile phone, higher will be the field that you receive. The communication is transported by this EMF. This is what we have. The frequency spectrum is used to be able to reach different parts of the territory. So what about 5G? Because we, as has been said, the 2G, 3G, 4G are already using a large part of the spectrum. 5G will reuse partially the frequency. So we get, for instance, 700. 700 is now used by 4G. 5G will reuse partially this spectrum resources in order to cover all the territory. What is new is the 3.5 or 0.7, depends on what you say, but is the frequency band between 3.4 and 3.8 gigahertz. In this area, specific antenna will be used, the massive MIMO antenna. I will go after. And the other things that will be new is to use the millimetric wave, 26 gig. That means that from 24 to 27 gigs. But I will not spend a lot of time on this because this high frequency will be, first of all, used, commercial use in minimum 3-4 years. And second thing is the exposure is mainly absorbed by the skin. What is the field emitted by base station? The field emitted by base station depends on the network and technology. I put some view, you see the FM is something that is flat. What we have in GSM is we have traffic at the beginning was low traffic during the night, and high rush hour, high traffic during the day, UMTS is much more larger. So we can say from 6, 7 in the morning up to 24 in the night, the traffic is high. So to what we have now to check this, you can, as it has been said by Azedine, you can go on INFR, you can get a lot of information. But when we look at the current median value of what is the field emitted, indoor or outdoor, because we spend a lot of time indoor, from 2014 to 2019, the field is, the median is about some things like 0.3, 0.4, 0.5, depending if you are outdoor or indoor. Mainly, these fields are coming from mobile telephony. But you see, 0.3, 0.5, we are far away. And at each time, you say, okay, what is, if I want to say, what is the power emitted? You go back to the previous formula, you say, okay, if you want to have the power transported by such a field, you just have to say, what is 1 volt? 1 volt, what is the energy transported by 1 volt per meter? 1 volt per meter, that means that your energy is 1 multiplied by 1 is squared divided by 400, we say 377. So that means divide by 400, and you will see that in fact it's some things like 0.2 minus power minus 2. So it's watt per meter square. So if you are able to get what is emitted in 1 watt, you get a very small value. You see, it's not comparable. We are far from any watt absorbed. Now we can say, what is the field emitted by 5G? For the frequency in the low band, what we will have is more or less the same as we have now, because the 5G will use dynamic spectrum sharing. For instance, we can say, okay, the frequency band used by 4G in the 700 band will be shared with some 5G system, or directly, or using an encoding from the 4G installation. That might mean the power emitted will be the same. So I think that the main question we have is the 5G with the massive MIMO and with the 3.5 gig. In this case, that's been discussed, we have the massive MIMO should have been so high gain, because if you say you restrict the beam, you increase the gain, so you can have higher field. Instead of 1, you will have 1 volt, you can have for 1 millisecond, for a few milliseconds, you can have a few volt per meter, 10 volt or 15 volt. But the question is, first of all, we can say during 5 milliseconds, you will have the beam linked to the synchronization, more or less, who want to speak. And after that, we have for the next 15 milliseconds, we have the traffic beam, and the traffic beam will be distributed among the people who have requested. So it depends on the strategy, and also on the strategy on how many people will use the 5G traffic, and more since it's a TDD, we can have few slots for downlink and few slots for the uplink. Really, what we can expect from this is, if you look at the exposure, instantaneous exposure at a given millisecond, yes, what is emitted by the base station can be higher. But if you average over few seconds, few minutes, it will be something that is not, it's not linked to the technology, it's linked to how many data you will transmit, how many data you will receive. If you receive a lot of data, of course, you will have the downlink exposure more often, but if you do not transmit at all, if you don't need to have any data, you will not receive a lot. You can have the exposure when you are using 5G, but also if you have people in your nearby that is also using the 5G. I go quick because I think that time is running. What is the field emitted by mobile? The field emitted by mobile is what we can expect is about the same power, because the power emitted are linked, the power emitted by mobile phone are linked to what is accepted, what is compliant with the usual rule in Europe. And for the maximum power, I think that we will not have a large difference because we say at 700 or 2000, it will be exactly the same, because if your mobile phone is able to emit a given power at 700, whatever it will be 5G or 4G, it will emit the same things. If we are dealing with the new frequency 3.5, in this case, it's about the same frequency range. It's not a frequency range very exotic, and so we can have about the same power. So the field emitted by mobile in this case will be about the same. Main difference is maybe you can take advantage of the gain of the antenna, because the beam is oriented the signal toward the user, and so that means that the field, the power emitted by the mobile phone can be reduced. So I think that is what we have to say. So first, the commercial phone operating in the 7 gigahertz are on the market now. These 5G phone will have multiple antennas. They are supporting as for 4G WAN, many protocol. I think that means that we have to use the actual measurement protocol to measure the ACR induced by this phone, but more or less the field emitted are about the same. But the time variation will be slightly different, because you have less continuity for the emission will be less continuous, not continuous, but we can have high variation. The actual power is limited. What I said is you take advantage of the gain base station. And dealing with the RF exposure remainder, so as it has been said, we have the incident field to absorb a part, and the exposure is quantified using the specific absorption rate, that is more or less the proportional to the conductivity times the E squared. It has been explained by Ron. And to assess this, we have to go through the numerical dosimetry. It's often used to design phone and or also to design the animal exposure setup, as the chamber shown by Ron. And we have also the experimental dosimetry, because the dosimetry is invasive. You have to put the sensor inside something, so it's often used with phantom. And it's also used to check the compliance of mobile phone. The ACR assess using numerical method, we have a large experience with simulation, and I disagree with Ron. He said that the head exposure will be, the children head exposure are slightly different from the adult. Not at all. The size of the head of the child is about the same as human. You see that the low part of the skull of the head is is changing, but if you say at the brain of a child is about the same as an adult one at 4 years old. So we can consider that the children exposure, it's about the same as an adult one if you consider that the age is above 8-9 years old. And we have also, what is important, we can, because I see it's also important, how can we combine what is coming from a mobile phone and what is coming from the base station? One is in watt per kilogram, the power absorbed in the tissues. The other one is in volt per meters. We have, by simulation, we can compute how the incident power can go inside the body. And as you can see on this screen, the body has a specific, the body's anatomy, morphology is able to grab the energy, and its capability to grab energy depends on the frequency. When your size is about the size of the wavelength, half wavelength, so that means in a human body 1.7, depending on age and so on, you will have a higher exposure, higher absorb body. You can have an higher absorb power, and in this case you are around between 60 and 100 megahertz, and at higher frequency your system it's much more stable and depend on there's no resonance, there's no body resonance.
Je dois te demander d'accélérer.
Oui, ben, moi, j'ai pas eu beaucoup de temps, c'est bon. And I agree. So the access during simulation is okay. Sorry. We can assess also using the exposure, using the measurement. So we can do measurement. We can measure SCR. So we have in this case some system like this RC system, or there is a CMG system. Anyway, this is what we can do in Europe, in France. We have also the ETS bigger system. In Europe, the RED directive requests that you, before to put a system on the market, you shall comply with EU recommendation, and that is based on ICNIRP. And ICNIRP, I also disagree with what has been said by Ron. ICNIRP is not looking at a thermal effect. I know that many people say that, but in fact, ICNIRP is looking at the SSL for exposure for both short and long term. So that means that the review, when we read the ICNIRP document, you see what has been done in research, what are the acute effect, what has been the proof effect, and we see that now it's only the thermal one. That does not mean that we stop everything. I am involved in Interphone, Geronimo, so that means that from the epidemiological point of view, we continue to look for any effect. Is there any effect on long-term effect? But at this time, we have a lot of data that what is proved is only the thermal effect. So sometimes we reduce, ICNIRP is looking for non-effect, and we reduce to thermal effect. I prefer to say it's only, they are looking for non-effect. So this is what we are doing. That not means that we are not taking into account that question exists. But to say question, that's not mean that we will solve everything. And in this case, they review all the studies. We perform the measurement, and we we can perform the in situ as it is now, and we are able to use sensor, and we are now able to use the artificial intelligence and statistics. So we perform the measurement using the sensor network and using the neural network. And the artificial neural network were able to interpolate and to deliver the RF exposure maps. And the statistics is the same. So the challenge is for us is with 4G, the exposure depend on the duration, throughput, and amount of data transmitted. With 5G, I think that uplink and downlink exposure will depend on usage and the network performance. And what we say is the standard that are presently developed under the umbrella of CELENEC and IC. So all the systems put on the market are in line with the EU recommendation, and this EU recommendation at this time is in line with what has been agreed by a lot of expert group. We can discuss if we investigate new things, if this review has been done in order to take into account all the questions, all the results. That it's not fair that we say we have some result that is proving that we have something. I think that what has been, for instance, Ron explained what has been done in Mtp. Okay, I have some question about the thermal monitoring, because no one has monitored the temperature of the rats during the exposure. So of course they monitor the temperature before, but it's a very typical thing. Rats, the length of life for rats is not 10, 20 hours. It's only 2 years. So that means during this, the thermal capability decrease. So how do you know if the 6 watt per kilogram used for the exposure was not inducing thermal effect? This is one of the questions. And okay, and I think also to discuss, to say, okay, the IARC has ranked the EMF as possible, and it should be because of a possible result of Mtp. We have to rank it at 2A, that means probable. In French, possible et probable is not exactly the same. And I think that what we can say is, okay, Mtp has to be replicated. I fully agree, because what has been pointed out by Mtp is very important, and so maybe we have to replicate to see if what's about the thermal impact, because I read some document and where people say the thermal impact could have bias what we see in the result, for instance. So I will stop on this, and I think it's my time. Thank you very much.
Thank you, Joe. I will address you a couple of questions. The first one is, we addressed it a bit with, as it did a bit before. We understand that 5G will have an entirely different working mode than the previous generations, and that the exposure will be dominantly determined by the actual traffic. So this will generate some kind of hotspots in the network where the field will be very active because traffic will be very active, and the average of the network will be mostly idle or with much lower field in average. So how can those hotspots be pre-simulated so as to give rise to some efforts to detect them on the ground, in the field, measure them, and take some mitigation actions?
Yes. I don't like the term hotspot, because I mean, it does not have any reality. The reality is that when we do a simulation, as I said, before installing any base station, we do simulation. When we do the simulation, we consider it does not exist. We consider all the beams existing everywhere at the maximum power. We add to that the 4G, and we add the 3G, the 2G, and all the transmitter that is active, that are activated. Sorry. So we consider all the transmitter are maximum power, and then we cumulate all the propagating fields. For the 5G, as the beam is moving, we simulate as is if the beam is present everywhere. And we make sure that we don't exceed the limits in any single situation. Is it clear? Régis?
Yes, it was.
Joe?
Yeah, it's okay. It's okay.
Sorry. Thank you, Azedine, for these details. It's quite technical, so I think that everybody needs to do some thinking about it. I suggest that we move to the global questions. We have a few of them. The first one is, if we look at the incredible amount of money, time, and effort that NTP has spent on its study for 10 years and $30 million, at the incredible number of studies around the world, some it's mentioned somewhere more than 4,800 studies only related to the mobile industry. That must be in the IGAS report. How could one move to AC2, and with the result that those studies, their results, their methodology are criticized, their results are not accepted in a general way? How can we move to a much more consensual situation in which the methods would be agreed, the way to produce and show the results would be agreed, so that only a few such studies could be started worldwide in a kind of international move to really shed light on the situation instead of this incredible waste of money, efforts, and studies. Who wants to start with that? Joe, maybe?
Yeah, just to say, I understand you see, NTP, as you have seen, is you need reverberation chamber, you need exposure before to start the analysis. You will have to perform huge amount of data to see what we are doing and so on. And you are dealing with living matter. So it's not like an engineering with a mobile phone, we push on the button and you have the result. So that means that, first of all, one study is never able to give you the full answer. So NTP is one. Now the NTP is now doing, NIHS is doing the same study at different frequency, and they take into account the criticism or the concern of the agency. So they will consider the temperature monitoring of the rat, not only before, but for all the duration of the study. And it's not only in NIHS, I think that Korea and Japan are now starting, they design an NTP study in order to confirm in film what has been more or less discussed, discovered, and after at the end we will have the result. It's somewhere frustration because we will not have the direct result. Yes, but it's when we are dealing with, it's exactly with the COVID now. We put a lot. It's not only few million, it's a few hundred of million. And you see that you are not able to get a quick answer.
Okay, Ron, maybe could you add something?
Well, so I came from the health effects side. In order to create the NTP studies, I had to work with the engineers and physicists from the National Institute of Standards and Technology plus ITIS. I think when there is this kind of two opinions, that the two groups need to interact a little more for the engineer physicists to understand the biology and the biologists to understand the engineers. So, for example, when I hear about 5G, and the question I raise is, are we going to have exposures to people under the assumption that it is safe? So when you hear that with the 26 gigahertz, it's mostly absorbed by the skin, what is the effect then for people outdoors when they're exposed to UV light and 5G radiation on their skin? What effects does it have on the eyes? We don't know. I would like to see what are the health effects data prior to implementing a new technology rather than learning about the health effects afterwards. And I think if the groups got together and explained back and forth, that maybe some middle of the road could be obtained.
Okay, so thank you, Ron. Basically, you have anticipated on the following question, which was, what could be the focus of a next step of NTP-like studies? Should it be on precisely on exploring the situation at the different new frequencies, or should it be more focused on the precise cellular mechanisms that could be incriminated following the existing NTP study?
I think the emphasis right now should be trying to understand mechanisms. And there is I'm not sure if it's well established, but there are numerous papers demonstrating the induction of oxidative stress or reactive oxygen species. And that is related to DNA damage, where DNA damage has been reported frequently. I think that issue needs to be explored more. And if that helps to explain any of the NTP results, that could be used as an early indicator of any health risks with new technologies that develop. Right. I don't think you can test every frequency, but it would be nice to know what are early indicators of potential adverse effects.
Okay, I would just again ask the question, how could one move to more coordination internationally and ensure that the various health agencies in multiple countries, that's especially the case in Europe, where you have as many health agencies as countries, so that's 28, could participate in the definition of objectives and of the methods, and make sure that they would not be unsure or uncertain as to the adequacy of the methodology?
That could be very difficult. I was a participant in the 2011 IARC review, and there were people who walked out of the discussions because they felt very strong on their own position prior to the IARC having a vote on the level of evidence. I don't know how you bring people together, but there could be something under the WHO for that effect.
That's probably what should take place. Thank you, Ron. I'd like to raise a last question, which probably is more for...
May I add some things? Because
yes,
yeah, I understand your question. And you see, when the NTP, what I said is, last month I had a meeting with Michael White, that is now leading the future or the ongoing replication, not a replication, but a follow-up of the NTP study. So there is some, we can say there is no inter-comparison, there is no cooperation, but there is some cooperation. There is. Michael White is dealing with the new NTP, is leading the new NTP, but is also in the other group of the Japanese and Korea NTP study. I am in the Korea and Japanese study to see what are the exposure, what is the bioassay and so on. I think it's not, we have a lot of study that has been at the beginning, 10, 15, 20 years ago, I can say yes, we have a lot of studies that are not coordinating. Now, the French studies are more or less coordinated, by ONCES. ONCES is in the International Advisory Committee of the WHO. We have between Asia and between Europe and US, we built a GROW that is more or less in the international collaboration. So we exchange what we are doing. No, really, there is some cooperation, hopefully.
I didn't mean to imply that there's no cooperation. I think there are issues, though, that aren't being discussed in terms of how to interpret and implement guidelines. So, for example, I don't understand why 0.08 is acceptable for whole body exposure, but 2 watts per kilogram is for target specific. If you want to understand target specific risk, why not reduce the local level to 0.08 rather than claiming that the whole body exposure must be limited to 0.08, even for an organ like the brain, which will receive has an acceptable limit higher than the whole body limit. To me, it doesn't make sense, and I would like to see that explained.
Thank you, Ron.
If you read the ICNIRP, you will see that the scheme has a different behavior about to absorb, and so this is what they explain. It's not only different tissues have different capability to absorb, not dealing with any rise of temperature. They absorb differently.
Thank you, Joe. I suggest we close the discussion at this point. There is one last question that we would like to raise on account of the audience, which is relates to which kind of information will be available to the general public in the case of 5G, relating to the actual exposure that they get in any given place, where they live, where they work, where they walk. We understand that the exposure will be very much traffic dependent. How can, and today, people can get a fair view of the exposure they get because measurement is fairly simple. They can even do it themselves with some probes, which are in the range of 100 or 150 euros a piece. Can you comment on which kind of value can be answered to someone asking, well, I live at this place as it does today. What's the exposure I get? And is this something that people can approach by themselves, or will this become exclusively the matter of specialists with very specialized equipment?
I will answer. I think, first of all, it's honestly, it's more complex than having a probe, because you need to know how to have frequency selective and so on. So I think that this is a bad aspect. It's it's a complex approach. But the good aspect is you have to request a measurement. If you are afraid, you can just have to go to your mayor or to your association and to say, ask for a measurement. There is a budget at the INFR level, and you can get the level of exposure in your home, in the vicinity of your home, and so on. Today, the INFR website is open, and they will now cover 5G. It starts now. So to say it's complex, yes, it is complex, but yes, the INFR and the French approach, it's not the case everywhere, but in France, we give the capability to everyone to have a measurement, and you don't have to pay. We just have to ask to the mayor.
Okay, so we understand that the INFR will issue, certainly for 5G, a protocol that will explicit how measurements are done and how results of measurements are published to the people who have asked them.
Yes. The protocols are set by INFR. If the question is coming from France, I don't know. Huh? If it is coming from France, go to cartoradio.fr. Cartoradio.fr, and you have all the measurements. You type your address and you get all the measurements that have been done by INFR since the 5 last years. And as said by Joe, if you need a specific measurement in your house, go to see your mayor or ask the INFR to do the measurement. It's free of charge.
With IEC, within the International Electrotechnical Committee, we are working since about three years on how to measure 5G. So I didn't say it's easy. I didn't say that it's very easy because it's traffic dependent, the complexity, but 4G was not easy too. So that means that we improve our capability. There is a high variation, okay. It will depend on the traffic, yes. But we can, this measurement has been done. There is some prior measurement performed by NFR. There is a report. I put it in my slide so we can get it. But the question is really, a lot of things has been done. So the question is really, if you want, my feeling is, if you want, what is unknown is now, since we don't know how 5G will be used in the future, since the 5G exposure match what is emitted by your phone and the relative exposure, plus what is emitted by your 5G, by the base station, it depends on the traffic. Yes, we are starting. We don't know exactly what will be the traffic, but what has been done by NFL, say, okay, we will base our measurement because you have to call the beam. You have to say, now I will be an active user, the beam will come to me and I will measure. In this case, we assume that, for instance, the user will download or will upload a lot of data. According to this is why they have 1 second, 1 giga, 10 giga, or 10 gigaoctane, or so on. So it depends on how you use. We don't know at the end what will be usage, but what we know is instantaneous measurement is now a lot progressing.
Okay, thank you, Joe. We're already way beyond the extreme limit we had set before. So this is 7:22. We really thank all the participants to this meeting. We especially thank the three of you, Ron, Azedine, and Joe, for the preparation you did and the quite enlightening exposés you have done for us all today. And we wish you an excellent end of week and weekend.
Thank you.
You too, and thank you, Ron, to be in touch with us.
Well, thank you for being in touch with me.
Thank you very much. Bye-bye.
You're welcome, Ron.
Bye-bye.
Bye-bye.